Okay, we're looking at exercise 303, scale diagrams. A scale diagram is usually a reduction of a real object, but it can also be an enlargement of a very small object. So, for example, if I've got the plans for a house, of course the drawing on the paper will be smaller than the house, but let's say there's a bacteria or a microbe, and you see that in your biology book or in your science textbook, the picture is bigger than the real, like an insect or an ant or something. A drawing of an ant might be a lot bigger than one in real life that you might see in a book or something, okay? So scale diagrams are usually a reduction, but sometimes they can be an enlargement of a small object, like an insect or a computer microchip. Now, the scale used in a scale diagram can be shown to you in a few different ways. Now, but there is one thing that's in common. A scale is always written as a ratio of two numbers, and it will be the first number dot dot to the second number. Now, the first number always represents the drawing on the page that you see, and the second number will be the ratio of the real thing, like what you might see in real life. So the first number is always your drawing or the map. The second number represents the real object. Now, an example here. For example, a scale of 1 is to 100. Remember, the first number is what's on your paper. The second number is what's in the real size of the object. Means that the real object is 100 times bigger or smaller. So if this represents your drawing or the map, and this is the real object, this means that the real thing is 100 times bigger than the drawing. Does this make sense? So if you see a scale 1 dot dot 100, like I said, the first number represents the length on the drawing or your map on your paper. The second number is the real actual length, or how many times bigger it is. 1 is to 100 means the real object is 100 times bigger than the drawing, or the drawing is 100 times smaller than the real object. See a scale written like this with the bigger number first, the smaller number second. The first one is always your drawing. The second one represents real life. The real life number is smaller than the drawing number. So the real thing is smaller than the drawing. Now, how many times smaller? See the difference? It's 5 times. So it means that the drawing is 5 times bigger or smaller? No, the drawing in this one is bigger than the real object, or that the real life object is 5 times smaller. Now, the reason I'm writing it both ways is that when we do worded problems, that's how I want you to think. The real thing is 50 times bigger. The drawing is 50 times smaller, and that will help you answer your questions, okay? If you just remember that simple, basic thing, all right? Now, this example is just from your book, and it says write each of these scales as a ratio. So with the first one, it just says that that's 20 kilometres, but you need to measure the length, and I wouldn't measure from 0 to 5. I'd measure from 0 to 20 because it's more accurate when you're measuring a longer distance. You have less error in measurement. So we need a ruler to measure from 0 to 20 and see how many centimetres that is. Meters. So here with A, we can see that 4 centimetres dot dot 20 kilometres. So 4 centimetres represents 20 kilometres. Girls, do you think you can, I know that, so girls, can you see that these units are different for a start? All right, what could you do? You should put them in the same units. Or can you could divide them both by 4 at the moment. I know our units are different, but what would 1 centimetre equal? Good. So 1 centimetre dot dot 5 kilometres. So which is the same as 1 centimetre is to 5 kilometres. Look, we could have measured that 1 centimetre, but like I said, you do get more error in measurement. I would not have gone, look, 1 centimetre is 5 kilometres. It's much more. You can, but just to be sure, it's better to measure the whole thing, that the 4 centimetres is 20, then you don't get the error in measurement. Now, so what we're going to do, we're going to put 5 kilometres into the same units as centimetres. But we can do it in 2 steps. Girls, 1 kilometre is how many metres? Yep, so I'd write it as 5,000 meters. What you don't want to do is to do it in one step, because you could make a mistake. Now that's the same as, so notice what I'm doing. I'm just changing the way that 5 kilometre looks. 5 kilometres is 5,000 meters. So this is equals 100 centimeters in a meter. So if I'm going to change that to centimeters, I need to add another 2 zeros. Only because it's a whole number. So now, yes, my thing is, that distance was 4 centimeters. On the map represents 20 kilometers in real life. That's the same as dividing these both by 4. 1 centimeter represents 5 kilometers. I could have just measured that there anyway. Now I need to make the units the same to write it as a proper ratio. So I need them both in centimeters. It's always easier to change big units into small, okay? So 1 centimeter is to 500,000 centimeters. Once the units are the same, you can drop them off. So therefore, part A, to write that as a ratio, that scale as a ratio, that first one is 1 is to 500,000. So what does that mean in words? That the real thing is how many times bigger? 500,000 times bigger than your map. Okay, that's what it means. Or your map is 500,000 times smaller than the real thing. Now, if you think of ratio that way and scale diagrams that way, all the questions should be easy to answer. So you could either put them both into centimeters or both into millimeters. If I put them both into millimeters, I know that there's 1,000 millimeters in a meter. So make sure that you're putting the units. So now that the units are the same, drop the units off. 10 is to 1,000. But I'm supposed to have a simplified ratio. So what can I divide those both by? 10, and I get 1 is to 100. Or if you wanted, you could have done them both into centimeters. 10 millimeters is 1 centimeter. 1 meter is 100 centimeters. This one looks a bit easier. Now that they're both in centimeters, units are the same, you just drop off the units. 1 is to 100. You get the same answer. Okay, so keep going with C, D, and E. Is to 0.4 millimeters. I can drop the millimeters off. 10 is to 0.4. Now, you know, you can, what do you think? Yeah? Well, you could times both sides by 10, but we're still going to have to simplify. We need whole numbers. I really need to be multiplying both sides of the ratio by 10. That will give me a whole number. Does that? I need the 0.4 to be a whole number, so move the decimal point 1 place, which is multiplying by 10. So I'm going to multiply both sides by 10, and I'm going to get 100 is to 4. So I'm multiplying both sides by 10. Now tell me what you can divide both those numbers by. 4. So divide by 4, divide by 4. I get 25 is to 1. Oh, because the only way to get a decimal, you can't divide, you'll need to multiply. So you know when we... No, you're not allowed to leave decimals in a ratio. You need to make them whole numbers. So we need both whole numbers. So we need whole numbers in a ratio. On your calc, you can do it like this. You go 10 fraction 0.4, which is 10 ABC 0.4. Look, the numerator is bigger than the denominator, so you're going to get a mixed numeral, but make it back into improper fraction. And you should get the number 25, but that means 25 over 1. Just means that the number on top is 25 times bigger than the one on the bottom. It may not be the best one to use your calc for. So if you're ever simplifying a fraction on your calculator and you just get a whole number, it's always over 1. See, if I did 0.4 over 10, I'd get 1 over 25. 1 centimetre equals 2 metres. We know that 1 centimetre doesn't equal 2 metres. It's 1 centimetre on the map is 2 metres in real life. What's this one? What do I do? I need the units to be the same. Yeah, we just change the way this one looks. It's 200 centimetres. Now that the units are the same, we drop them off. Now you just got to be careful. There are times when I needed to multiply both sides by something, and sometimes you have to do that. But if you're just changing the way one of the units looks, You just fix it, like 2 meters is 200 centimeters. I don't go and multiply both sides by something here. All right, so that scale there is 1:200, meaning that the real thing is 200 times bigger. And the last one is another measuring one. Textbook for this one, and we're getting, the textbook is saying it's 4.8. I know that's slightly different here, but in the actual textbook, we've got 4.8 centimeters is 60 meters. So we're just going to use that because there's been a bit of a distortion with the photocopying. So 4.8 centimeters is 60 meters. So that's what we're going to go with. 4.8 centimeters is 60 meters. All right. Look, you can make the units the same at the moment, but you don't have to. What could you do? How many centimeters in a meter? So 6,000 centimeters. Now that the units are the same, drop off the units only when they're the same. Okay, what can you divide? Remember, it's like simplifying a fraction. You're going to divide both sides by something, or you could put this in your calculator. But what could you divide them both by? Good. Divide both by 4.8, and you'll get 1:2. So we need 6,000 divided by 4.8. That's it. Good. Okay, very good. 1:1,250. Or it could have, yeah, okay. In other words, the real object is 1,250 times bigger. 6, it says by measurement and calculation, find the real length in centimeters of this tennis racket. We can see that the scale is 1:12. That just means that the real thing is how many times bigger? That's all it means. Remember, the first number is your drawing, the second number is real life. Let's measure this racket. Yep. So we're getting 5.5. Okay, so that has gotten a little bit bigger with the photocopying, but measuring directly from the textbook, we're getting 5.5 centimeters. So we've got 5.5 centimeters on your drawing. So yeah, we just look at this and we say the real racket is 12 times bigger. That's how I do it, nice and simple. What does 1:12 mean? The real thing's 12 times bigger, so therefore the real racket, keep the units the same, it's 5.5 centimeters times 12, because it's just 12 times bigger than your drawing. So this is what we want. You want to be saying to yourself, real racket's 12 times bigger. 5.5 centimeters on the drawing, the real racket is 5.5 times 12, which is 6. So the real racket is 66 centimeters. So it's as simple as that, okay? This same example, the diagram of a house is drawn to a scale of 1:100. So we know that the real house is 100 times bigger than this drawing. It says by measurement and calculation, find the actual height of the door. So you'll need to measure the height of this door. What are you getting? So the measurement, we're getting 1.9 centimeters. So we've measured the height of this door and it's 1.9 centimeters on the drawing. So how big is it in real life? So it's 1.9 centimeters times 100. So whatever you've got, it's 100 times bigger in the same units. So it's 1.9 centimeters times 100, yeah, which is 190 centimeters, which is, yes, 1.9 meters. So remember, the real object is 100 times bigger. So the drawing is 1.9 centimeters. The real object is 1.9 centimeters times 100, which is 190 centimeters, which is 1.9 meters. And you should be using an element of common sense here because you all know how tall you are. That door is actually a bit low. Should be about, oh, actually, no, it mightn't be too bad. It says, part 2, what is the scaled length in millimeters if the house is actually 9.5 meters long? So remember, we can't see the length of this house. We've only got the width. This is going back. But we just know, remember how the scale, that the real thing is 100 times bigger, or we call the drawing the scaled length. So if the scale is 1:100, it means the drawing is 100 times smaller. Does that make sense? Okay? So, part 2. The real length equals 9.5 meters. The drawing is 100 times smaller than the real object. The drawing is 100 times smaller than the real object, than the real length. Does that make sense? All right, that's what 1:100 means. So therefore, the scaled length of the house will be this 9.5 meters divided by 100. Now, of course, you're not going to be measuring in meters on your page. You can either change that 9.5 meters into centimeters now before you decide to divide it by 100, or you divide this by 100 and then change your answer to centimeters. All right, because what am I going to be measuring on this page? I'm measuring things like centimeters on this page. So you've got two options here. So the scaled length, which is your actual drawing length, okay? This is the crucial thing. The drawing is 100 times smaller than the real object, and that is from your scale 1:100. So scaled length, 9.5 divided by 100 is 0.095 meters. Now, who walks around saying I just measured 0.095 meters on my page? Make that look a little bit more everyday language. 9.5 centimeters. So we're going to convert this distance because that's something you measure on the page. So it's got to be something you're going to measure in, which is you measure on your page in centimeters or millimeters, right? So make your answer in that. So that is the length on the drawing, but change it into units that look better, all right? Now, you could have changed this 9.5 meters before you divided by 100. Yes, because we know that 1 meter is 100 centimeters. See how 100 is with the centimeters and 1 is with the meters? You've got 100 more centimeters for every meter. It's 100 times bigger, so you're timesing this by 100 to get that. In our next lesson, here we can just see the front of the house. In our next lesson with house plans, you will see the side of the house as well. So if this was the next lesson and you could see the side of the house, on the page, the side of the house would be 9.5 centimeters long on the paper. Example 7, an architect made this scale diagram of an extension to Natalie and Bill's house. The scale is 1:200, meaning the real thing is 200 times bigger, or the drawing is 200 times smaller than the real thing. Saying, what is the length of the porch in meters? Don't worry about the meters bit. Let's just measure the porch. And what have we got? I'm getting about 2.8. Yeah, let's go 2.8. So the porch, the drawing. Porch on the drawing is 2.8 centimeters. Okay, we now go to the scale. And what do we say? The real porch is 200 times bigger. You don't have to write this down, but I'm just writing it down. So therefore, the real porch, the actual porch, is 2.8 centimeters times 200, which is 560 centimeters. Okay, now make that into meters. How many centimeters in a meter? So yeah, so we know that we've got 100 centimeters in 1 meter. So when you're going from centimeters to meters, you divide by 100. So the length of the real porch is 5.6 meters. Okay, so we're going to need, so that was the length. We were looking at the length. Now we need the width. Okay, let's measure. The width of the porch on the drawing is 6 millimeters. So therefore the real width is, girls, how many times bigger? 200 times bigger which is 6 times 200 is 1,200 millimeters. Be very careful. Our first ones were in centimeters and now I'm in millimeters, but it doesn't matter. 6 millimeters is the width on the drawing. The real width is 200 times bigger than that, which is 1,200 millimeters. Let's put that into meters because our other length is in meters. So what have we got? How many millimeters in a meter? 1,000 millimeters in a meter. So the real width of that porch is 1.2 meters. Now you can work out the area of your porch because we're trying to work out the cost of tiling the porch. So what we've got, our real porch, our porch is like this, 1.2 meters, 5.6 meters. So we can work out the area of that porch. It's 5.6 meters times 1.2 meters, which is, no rounding, 6.72 meters squared. And in the question, we're told that the cost of tiling the porch is $62.50 per square meter laid. So we go 6.72 times $62.50. That will be the cost. So for every 1 meter squared, it's $62.50. Tiling this porch is $420.